We are going to continue graphing quantitative variables today with a primary focus on histograms. And so histograms look very similar to bar graphs, but remember, we only use bar graphs if we have categorical variables. We will use histograms for quantitative variables. And it is one of the most common graphs that you'll see with quantitative variables just because they're very easy to make with technology once you kind of get the hang of things. In order to make a histogram, you're going to have to look at the overall range of the data and then divide it into what we call classes, so essentially like groups that have an equal width. And then you're going to figure out how many individuals fall into each class. If you're just looking at how many, that's the count, and we would call that a frequency histogram. You also can make what's called a relative frequency histogram if you find the percent of individuals that fall into each category. You're then going to label and scale your axes. And so in order to label and scale the axes, the x-axis is going to have your classes, and then the y-axis is going to have either your frequency or relative frequency. You will not leave space between the bars in a histogram. So here it says adjacent bars should touch, unless you have a class that does not have any individuals. In that case, there would be a gap. So here, we're going to go ahead and make a histogram from what's called a frequency table. So a frequency table just has the count along with the classes already. And then we can talk about how we would make a histogram from data in a few minutes. So we want to go ahead and label our axes. Our classes go on the x-axis. So 0 to 5, 5 to 10. You can see that we're counting by fives here. And then your y-axis is the frequency. So here we could label it frequency or count, but we can be more specific. Here they're looking at the number of states where they're looking at individuals born outside of the US. So the more specific you can be, the better with your graphs. So then to draw our histogram, we have 20 states in the 0 to 5% category. So we can go ahead and put that count of 20 in. And then we have 13 states in the 5 to 10% category. So we put that bar in with a height of 13, and then we continue that pattern. One thing to make note of here is this less than symbol. That bar means that it's less than, but not including 5. So this first bar here has all of the states that are up to 4.99999% foreign-born residents. And then this next bar is 5, and then up to, but not including 10. So with histograms, that upper class boundary is never included in the bar to the left. It's always bumped into the bar to the right. So some things that we want to be careful of when we're looking at histograms. We don't want to confuse them with bar graphs. I had mentioned them at the beginning of the notes today. We want to make sure that we only use histograms with quantitative variables, bar graphs with categorical variables. Again, here there's no space between the bars. Here there is equal space between the bars. And then you don't want to use the counts in the frequency table as the data. So if I go back to this chart here, this frequency table, I don't want to say that my data set is just 20, 13, 9, 5, 2, 1. Instead, this is already telling me that there were 20 states in this group. So I went through that raw data set, which you can find on page 35, and I counted that there are 20 states in that category. And then I counted that there were 13 states in the next category. So again, this is not the data set. This is just how many are in each set. If you're trying to compare two distributions and they're not the same size, you should really consider using percents or relative frequencies on that y-axis if the groups, again, are not the same size. So if you wanted to compare adults to children and you had 100 adults and 400 children, you would want to consider using percentages or relative frequencies on that y-axis instead of counts. And then just because a graph looks nice, it doesn't necessarily mean that it's meaningful. So if you look at a graph and then you try and all of a sudden go to scale the classes in a certain way so that there's not any gaps, those gaps might indicate things like outliers or clusters in your data set. So you don't want to just come up with these wide classes to make everything nice and compact. Instead, you really want to look at what's a good window for your data set based on the overall range. So here's a summary of section 1.2, and then you're going to see me run through an example of creating a histogram using the graphing calculator so that you can see really how that works. And we'll focus on that again in class tomorrow. Okay, so we can use dot plots, stem plots, and histograms to describe quantitative variables and display those distributions. Anytime you're describing a distribution of a quantitative variable, that's where you want to talk about your SOCs. And again, for right now, our center and our spread are just going to be roughly described by the median and the range. But when we get into the next section, we're going to specifically talk about things like mean and median, standard deviation, something called interquartile range, to be a little bit more specific. And we'll also learn a rule for checking for outliers. As far as the shape goes, we had talked about roughly symmetric, skewed left and skewed right. And then remember, sometimes we had the graphs that were called bimodal, where you had two peaks. You could potentially have more than two peaks, and you would just identify as such. Again, describing all of those potential pieces when you're describing a distribution should be in complete sentences and should also be in context. And then just remember the difference between histograms and bar graphs. So again, histograms for quantitative, bar graphs for categorical. So for your homework assignment, you have some book work, and then you can try some practice problems on Khan Academy or watch some videos if you would like.